So here's an example. This graph alongside indicates the distance run by a sprinter in a number of seconds. You'll notice the x-axis is time and the y-axis is distance. So this is showing us the distance covered over a certain amount of time in seconds. This is a rate of change, the change of the distance per second. So we need to find the gradient, interpret the gradient, and explain if the speed of the runner is constant or variable, and what evidence do we have to suggest this. Well, first off, notice that it is a line. It is a straight line. There are no curves. There are no divots. There are no flat lines. There are no increases or decreases. It's just one steady increase. So no matter which 2 points I pick on the line, the slope, the gradient, will always be the same, which tells us that the speed is a constant rate of change. It is always increasing, and it is always increasing at the same rate. So I want to find the gradient, and I want to interpret that gradient. So I'm going to pick 2 points on the line, and I'm going to count the rise, which is the change in y, or the vertical distance, over the run, which is the change in x, the horizontal distance. I can pick any 2 points on the line. It doesn't matter where I pick them. So I'm going to pick this point here at 3,200, and this point, which is at 6,400. Now notice how these are partitioned off, and notice that it's not by ones, but it is a 30 here, a 60 here. This is a 200, this is a 400, so 300 would be right in the center, and so on. So the change in y, to go from 200 on the y-axis to 400 on the y-axis, is a change of 200 units. So I'm going to increase 200 units, and then I'm going to move to the right 30 units. To go from 30 to 60 is an increase of 30. So my gradient, or my slope, is a rise of 200, a run of 30. So it is 200 over 30, which I can simplify that to 20 over 3. So a slope or gradient of 20 over 3. What that means is that the sprinter runs 20 kilometers per, or in, 3 seconds. The reason I know it's kilometers for the 20 and the seconds for the 3 is because the numerator of my fraction, or my gradient, was the distance, and the denominator of my fraction was the time in seconds. So this is distance per, or divided by, seconds. We like to use the word per in English to mean division when we're talking about rate of change. So whenever you see that fraction symbol for the gradient, it means this unit per the other unit. So in this case, the sprinter runs 20 kilometers per, or in, every 3 seconds. So after 6 seconds, he would run 40 kilometers. After 9 seconds, he would run 60 kilometers, and so on. So, and as I said before, the speed is constant because it's a straight line. It is the same slope at every point along the run. So he is running the same speed the entire run, which is pretty impressive to keep that speed. Here's another graph. Notice right away that this graph is not a straight line throughout. There are little straight line segments that are connected, but it is not a constant rate of change throughout. So the slope is different between different points on the graph. So question C says the time interval over which average speed is greatest. So that means, where is the slope, or the gradient, the steepest? Because the steepest line represents the greatest speed. So again, this is time, but this is time in hours, and this is distance in kilometers, but it's the same idea. It's distance per hour, or kilometer per hour. So notice that it appears that this section from B to C is the steepest. We would need to check that mathematically to find the slope or gradient of that section, but that does appear to be the steepest, which means the distance is covered in the shortest amount of time. So it is the greatest average speed. To find the average speed for the entire trip, we need to find the speed of each section of the trip, add up the total of all those speeds, and divide it by 4, because there's 4 different sections. So basically, I'm just finding the average, or the mean speed for the entire trip. So I'll show you that with some calculations. So here's just all those gradients. I counted the rise over the run, the rise over the run between each point. I was able to do that because I noticed from 0 to y equals 170. It's a height of 170. I knew that from the coordinate 170. The x is 2, so I went from 0 to 2 on the x-axis. From